Hello, in this short video we are going to investigate the following challenging problem on the topic of matrix theory. Let alpha be a root of the equation x squared plus x plus 1 equals 0. If A is this given matrix, then a to the power of 31 is equal to. Pause the video at this point and give it a try to see which one of the given following options is the correct answer to the problem. Okay, so alpha is a root of this quadratic equation and a is this given matrix. We want to calculate a to the power of 31. So usually if you want to, systematically, if you want to calculate high powers of a matrix, then you need to diagonalize this matrix using the eigenvalues of the matrix. Okay, of course, this is not the case that all matrices are diagonalizable, but this matrix is a symmetric matrix, meaning that the transpose of this matrix is equal to itself. So it is completely symmetric with respect to the main diagonal. So definitely this matrix is diagonalizable. So I can diagonalize it and calculate a to the power of 31. But usually in lower level courses, we don't have to. Usually the questions are designed in a way that if you calculate, small powers of A, hoping for finding a pattern or something like that, you will be able to calculate the high powers. So that is why I will not start solving this problem systematically, especially when I see the question is a multiple choice question. So what I will do, I will calculate the first power, meaning a squared, to see what is going on, if I can find a pattern or something. So a squared means that I have to multiply this matrix by itself. So this will be multiplied by itself, so it will give me 1 over 3, and then I have to write this matrix and multiply it by itself to see what is going on. Okay, so I write it one more time. Okay, so now let us calculate this. So I copy and paste this 1 over 3 here. Then you know that I have to partition the left matrix to rows and the right matrix to columns, and then multiply each row by each column. So this row will be multiplied here, so 1 times 1 plus 1 times 1 plus 1 times 1, which will be 3. And then I will take this row and multiply it here, 1 times 1, 1 times alpha squared, add them up, so it becomes 1 plus alpha squared. And when I multiply this here, for the same reason, it becomes 1 plus alpha squared plus alpha to the 4th. And then I go to the next one. So if I multiply this by that, it becomes 1 plus alpha squared, because this 1 will be multiplied here, alpha will be multiplied here, alpha squared will be multiplied here, and then I have to add them up. So now 1 times 1 is again 1. Alpha times alpha is alpha squared. And alpha squared times alpha squared is alpha to the power of 4. And then when I multiply this here, so this becomes 1 plus alpha cubed plus alpha to power 6. Yes? And then I will do the same thing here. So this becomes 1 plus alpha squared plus alpha to the power of 4. Multiply this here, it becomes 1 plus alpha cubed plus alpha to power 6. And finally, this to the last one. 1 times 1, alpha squared times alpha squared, alpha 4 times alpha 4. So this becomes alpha 4 plus alpha to power 8. So it seems a little bit hopeless, because apparently a squared is much complicated than a itself. But remember, alpha is a root of this equation. Of course, you know that the discriminant of this equation is negative, so definitely the roots are only complex numbers. But we don't need to, because if I want to solve this one and find alpha, first of all, I will find 3 roots. Sorry, I will find 2 roots, then I have to decide which one is the case. So this will be very problematic and tedious. So what we will do, we know that alpha is the root of this equation, so it will satisfy the equation. Yes. And what I will do, I will multiply both sides by alpha minus 1, alpha squared plus alpha plus 1 equals the right-hand side becomes 0. When I do that, this is a very famous combination. If you expand that, it becomes alpha cubed minus 1 equals to 0. So this means that alpha cubed is 1. So be careful. Alpha cubed is 1, but it doesn't mean alpha is equal to 1. It is clear that alpha cannot be equal to 1, because if I put 1 here, 1 plus 1 plus 1 is 3, and it is not equal to 0. So alpha is a complex number whose third power is 1, but we know that alpha is not equal to 1. But this will help me a lot, yes? Because first of all, this is 0. Yes, because 1 plus alpha squared is 0. So that one is also 0. But alpha 3 is equal to 1. It means that if I multiply both sides by alpha, alpha to power 4 becomes alpha. Okay? So then this means that this combination 1 plus alpha squared plus alpha to power 4 can be written as what? Instead of alpha to power 4, I put alpha. So then it becomes 1 plus alpha squared plus alpha. But 1 plus alpha squared plus alpha is again 0. Okay? So this means that this one is also 0. So then this means that this one is also 0. And then this one is also 0. Okay, so what about alpha 3? Alpha 3 is 1. If I raise it to power 2, alpha 6 also becomes 1. So this means that this is 1 plus 1 plus 1, so which is 3. Okay, so that one is also 3. But what about alpha 8? Alpha 4 is alpha, so alpha 8 becomes alpha squared. So this becomes 1 plus, so I would write it here, so 1 plus alpha to power 4 plus alpha to power 8 becomes 1 plus, instead of alpha 4 I put alpha, plus, instead of alpha 8 I put alpha squared. But again, 1 plus alpha squared is equal to 0. So this means that this is also 0. Okay? So you see that this is not hard at all. So what I have now, let me write it down. So a squared is 1/3. And then what I will do, so 3, 0, 0. And then 0, 0, 3. And finally 0, 3, 0. And now if I multiply this 1/3 inside, it will multiply itself into all of the entries. So this becomes 1. These are 0, 0, 0, 1, 0, 1, and 0. But of course, it is not, it's very close to the identity matrix, but it is not. But it is very simple to see that if I calculate a power 4 by multiplying a squared by another a squared, you will get the identity matrix, yes? So a squared is this matrix, 1, 0, 0, 0, 0, 1, 0, 1, 0. You multiply it by itself. And if you start multiplying them, you will get the identity matrix, which is the identity matrix of order 3, yes? But what is the question? The question is that, what can I write for A31? Okay, so A31 can be written as a to power 4 to power 7 multiplied by a to power 3. Yes? Because 4 times 7, 28, 28 plus 3, 31. But instead of a to power 4, I can put the identity matrix to the power of 7 times a to power 3. But identity matrix to power 7 is just identity. Identity times a cubed becomes a cubed. So we were able to show that a to the power of 31 is indeed a cubed. So that is the correct answer to the problem. Yes? So as you see, option D is the correct answer to this problem. Okay, so I hope that this video was helpful. Until the next video, be safe and goodbye. Thank you.